Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.FM radio. It is another Friday night, and this one happens to be November the 17th, 2017, at 9 o'clock in the evening for those of us here in the eastern portion of North America, also known Universal Time as, where are we at? 2 o'clock in the morning, November the 18th, 2017. So that means you're listening to us live. And, of course, come on over to the chat room where all the cool people hang out during the live presentation. My name is Marty Kunz with my co-host.
Good evening, everybody. It's me, Nick Evetts, KC2 VWR, or 2 Echo Zero Lima Uniform November. And guess who else is beside me?
Hey!
Yeah, Starstorm's here.
All right.
I'm still getting used to this new handset, Marty. New headset, rather.
All right. Let's say hi to everybody in our chat room tonight. We've got
High Optronics, Twisted, Astro One. There's me, there's you, there's Glenn. Hey, everybody!
Good to have you all here. And, of course, we invite everybody to come on over during the live presentation right now. Come on, join the chat room. And if you have any astronomy questions for you, we will answer them on air if we see them and if we get a chance to and all that kind of stuff. But we'll give it our best.
That's right.
Hey,
just replying to a comment.
I want to say you'll notice we've had some glitches, and we're also having some updates and improvements to our website. So you'll see things changing a little bit to our website and stuff like that. Some improvements, and to our radio show and stuff like that. We got backups. We got stuff fixed. We got some new systems and stuff. So we are increasing our improvements to Astronomy.FM. So hopefully things will be better. Let's see. Last week we had last Friday we had a glitch right at the last minute, ready to go on the air, and then we had a little technical glitch. So sorry about that. Let's see. We're going to have last week and this coming week. Space Pirates are out just for scheduling conflicts. We will be broadcasting next Friday night. For those of you in the U.S., United States, that is called Black Friday. It's a shopping day before the Christmas holiday, so we will be on the air for that. I'm not going shopping. You going shopping?
No, I do most of my shopping from home. I'm not stupid enough to get into Wally World, etc., and whatever.
Exactly.
As I say, it's been an interesting week with astronomically speaking.
Well, speak astronomical.
Speak astronomical. Well, yes, it's all right ascension and declination, dear boy.
There you go.
Okay. Now, I'm going to ask everybody. See, the chat room is definitely buzzing at the moment, so I'm going to keep out of that.
Yeah.
Some good stories coming up at the moment. Where should we go first? Ooh, LIGO. Let's go. Let's do LIGO. Okay.
That sounds like a commercial. Let's go LIGO time. Da, 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 da. Okay.
Well, okay. So the link is in the chat room. I'm just going to quickly just test it. Yes, it works.
It's there.
It's there. Well, on November the 15th, 5 months after space-time ripples jiggled LIGO's instruments, astronomers announced the detection of their number 6, gravitational wave discovery, which is the 5th from the merger of 2 black holes. The event, which is named GW170608, came from the union of the smallest black hole scientists have yet seen using this technique. Now, the waves hit LIGO at 0201 hours and 16 seconds universal time on June the 8th. This was during the project's second run, November 30th to August 25th. Their passage triggered the alarm at the site in Livingston, Louisiana. But the detector in Hanford, Washington was under routine maintenance and had its alert system turned off. But even with the ongoing tinkering, the Hanford interferometer detected GW1706082. Now, Europe's Virgo...
Eight also, you should say. Sounds like part of the number.
Potato. Although Europe's Virgo Gravitational Wave Observatory is still in its commissioning stage and didn't observe the event, the Virgo team did contribute to the analysis, which appears in a pre-print paper on arxiv.org. Now, the interesting thing is that from the signal's characteristics, the teams believe that the initial black holes were roughly 7 to 12 solar masses and created an 18 solar mass black hole. Now, what it is, this is radiating away a sun's worth of energy in gravitational waves. Now, the marriage happened more than 1 million light years away, so with only 2 detectors, the team can only say that this signal came from somewhere in a huge 520 square degree swath of the northern hemisphere sky. The spin of the final black hole is 69% of the maximum value it could be, once again matching the predicted 70% rate for black holes that have been created by the merger process. There's also no sign that the initial 2 objects were wildly tilted in their orbit as they spiraled into each other. So what's the most interesting about this latest detection? Well, it's the black hole's small sizes. They're similar to those from LIGO's second discovery, which is GW151226, which combined objects of about 8 and 14 solar masses to create a black hole of 21 suns. The rest was radiated away. Those initial masses are also similar to black holes discovered in binary systems with stars, which astronomers can find due to the X-ray glow of the gas the black hole is tearing from their stellar companions. It's considered to be exciting because this is a tantalizing possibility that if black holes discovered with LIGO and Virgo start falling into 2 distinct mass groups, then it's possible they're made different ways. With enough black holes, and the teams say that they'll need to find on the order of 100, so astronomers could start figuring out where each group comes from. What are we finding out about this discovery 5 months after it happened? Well, the teams were too busy analysing the 2 site detections from August. The 4th black hole merger, which was GW170814, and the first ever neutron star merger, GW170817. So we've hit a point where gravitational waves from merging black holes are no longer a big deal. Think about the ripples in the fabric of space-time. Ironic, isn't it, that I'm doing this article because what am I reading at night? I'm reading Kip Thorne's book on black holes and space warps and everything else. I'm actually averaging about 12 pages a night with a glass of wine beside me.
That's a lot of progress. Although that being said, I've read whole books in one time.
Yeah. It's not bad progress because there is quite a bit of math in it, and you really do have to think about what Kip Thorne is going on about. However, it just goes to prove that science is definitely stranger than fiction these days. We never thought this would be seen. We've now got it happening as I wouldn't say it's a regular occurrence, would you, Marty? But it's happening on a lot more than we thought it would happen.
Yes.
The upside, it's a nice big confirmation and slap on the back for old Albert, which just goes to prove that his relativity is still alive and kicking no matter what. Yep, thank you, Black Holes and Time Warps. That's the title. I can never remember it. It's just a wonderful book. It's nice, it's thick, it's chunky, and it's something I can get my brain wrapped around. It's evolution. It just grows and grows and grows.
There you go. Hey, I got something to report. A sunspot.
Sunspot.
There is an actual sunspot on the sun right now. Isn't that amazing?
I'm gobsmacked.
It's been like weeks since there's been a sunspot, and this one is so huge it's really small.
Yeah.
Yeah, of course. So it's actually interesting. It's a tiny little line of looks like 3 or 4 sunspots that are really small, but they're in a really nice, interesting little line. So if you didn't pack up your solar scope permanently, well, then you can still actually go out and look at the sun once more and see this interesting little tiny little line of sunspots. It's active region 2687. A little bit of activity coming from the sun, so a little bit of coronal hole, so some extreme northern latitude or extreme high latitude observers, I think it'd have to be mostly the North Pole, might be able to get some aurora within the next 24 hours or so.
Well, that would be nice. I know that a lot of people are active in Iceland at the moment, and of course this is the time of year they take the aurora cruises up there. Yeah,
I'd like to do that.
It's even easier. If I'm in the UK, just toddle up to Scotland. You can get very, very close that way.
Yep.
But did you know there's actually a sea change going on in the foundation of astronomy, Marty?
What is the change?
Well, what it is, let me just pull up the link just 1 second. There is a new telescope come on stream.
Okay,
and it's got a very famous name. It's called the Zwicky Transit Facility, and it's taken its first image. It's covering an area equivalent to 247 full moons in a single shot.
Okay.
Down with the link.
We are.
Well, it's kind of like a multiple mirror telescope, but now it's more like a multiple moon telescope.
Well, what it is, pictures have long served as the foundation of astronomy, but very soon astronomers will be turning to videos. Humans have always known that the seemingly eternal sky changes from night to night. The Aborigines even incorporated such changes into their mythology. But for the most part, studying celestial transients has required a great deal of patience or a willingness to trawl the archives. Only in the 21st century, in the era of big data, or data, take your pick, has astronomy had the capability to truly step into the time domain. And as I've always said, if you want to time travel, the best way to do it is to look at the night sky, because you're looking at a time machine that's going into the past. Mm-hmm. Now, no blue box required. Thank you very much. So, the Zwicky Transit Facility, ZTF, is part of the scene change. It took its first image of many, a 47-degree field equivalent. Now, that is the equivalent to the area of, as I said earlier, 247 full moons. It's captured a 24,000 by 24,000 pixel image. Now, the picture that's in the link that I put into the chat room shows a chunk of Orion. It shows the Orion Flame Nebula, the Horsehead Nebula, and this image precedes the science phase of the facility, which is due to start in February 2018 and complete by 2020. So, as I say, when you actually look at this picture, this is something you would have had to spend hours at iTelescope making mosaics to actually publish a picture like this. They've done it in one image instead of having to take huge numbers of images and then you've got to patiently stitch them all together and process it. This doesn't do this. So, as I said, it did its first light image on November the 1st of 2017 after being installed at the 48-inch Samuel Oskin telescope at Palomar Observatory. Now, the full resolution version is more than 24,000 pixels by 24,000 pixels. So that's got so much more. And the whole thing is the computers searching these images for transients or variable events are even trained to automatically recognize and ignore non-astronomical sources, such as vertical blooming lines like we get in a lot of our current pictures today. Mm-hmm. Yeah, Twisted Edge is pointing out Zwicky was one of his favorite scientists. The man was crazy and well. He had a brilliant intellect, and he would really get stuck into projects and do science that a lot of people really looked at as being impossible. And the guy had a reputation for being a very hard taskmaster, and almost impossible to get on with. Whether that's true or not, I don't know. I never personally met Zwicky. I would have loved to, and I maybe would have loved to have done some work with him. That would have been totally and utterly brilliant. But you know what? I think this is a great tribute to him. And of course, the ZTF is a sequel to the Palomar Transit Factory, which employed 3 telescopes, the 48-inch, the automated 60-inch, and the 200-inch Hale telescope to triage the night sky. So now one 48-inch telescope can do the work of 3 telescopes. So this is definitely going to be a game changer. And if you think about it, it's going to show how much electronics has improved. When it took 40 seconds to read an image from the Palomar Transit Factory camera, it takes only 10 seconds to read the bigger image taken by the ZTF, while the fast slewing telescope actually readies for the next image. So principal electronics engineer for Palomar, Roger Smith, describes how the Palomar 48-inch Smith telescope was originally built and then adapted in a video that's underneath the article. It is well worth watching and taking on board. Yep, that's right, Black Projects. He did use the Hale. So in ways, this is moving on, and this is giving us a greater ability to detect and explore and understand some things which really, unless you've got an archive going back at least a century and going forward maybe as much, you wouldn't know how to do them before. Mm-hmm. I think we're going to see an awful lot of good work in the 2 years that the ZTF project will be up and running.
All right. Have you ever imaged Barnard's Loop?
I've actually imaged that region quite a lot in the past. I still do on occasions with one of the remote telescopes I still use from when I joined it back in 2007. Ironically, Marty, that's when I met you.
I have never imaged Barnard's Loop. I've stepped in barnyard poop, if that counts, though.
No, it doesn't count.
Okay.
But things are really happening now for imaging from the ground itself. Yes, it used to be that the best optics we had were in space. Now we have telescopes coming online down here on terra firma that can do as well, if not better, than Hubble. Now, with Orion supposedly supposed to come into service in 2020, I would really love to see the Hubble get a upgrade, because I still think it has a lot of work to do. Unfortunately, here on the home planet, we have weather. It's called clouds. And I was amused today because one of my friends had a delivery of automatic focusing equipment from a certain supplier in the US who shares their name with a certain character from a TV advert for cars. Yeah. And they even now claim to sell cloud away guns. It's called the Zarkov. And and it's not supposed to be put into the hands of anybody who's descended from Emperor Ming of Mongo. And that is, if you go on their website, you can actually see the Zarkov gun. But whilst Marty's doing his next story, I will go and try and grab that link.
I'm doing a next story?
You're doing the next story.
Okay, I'll do a next story. Let's see, where do we want to go? Oh, yes, launch of NOAA's JPSS-1 weather satellite has actually been postponed until tomorrow. The countdown of 7 hours, 28 minutes, 11, 10, 9, 8, 7, 6 seconds right now. So it's actually going to be launched from California. It's at Vandenberg Air Force Base. So tune into NASA TV at 4 hours in the morning, my local time. So yeah, let's see, 7 hours from now. So that's going to be pretty early in the morning. But what I was wondering, I wonder what the track of a launch from Vandenberg would be, and if it would actually fly over my state. So I'm going to have to check that out in case there are more Vandenberg launches. Never even thought of it. Well, it shouldn't take too long to get here, so it should still be dark out. So that'd be interesting to see if I could see one of those launches, fresh launch flying over.
Okay, Marty, I found the link.
All right.
There we go. The link is in the chat room. And there is the Zarkov cloud gun. Just a little bit of tongue-in-cheek. I'm sure we all remember Flash Gordon.
Mm-hmm.
So as I say, enjoy it. I only wish it was true because it would probably be a godsend to astronomers. And it comes in a velvet-lined pressed tin case, and there's a certificate of indemnity that must be completed and returned to Zarkov Industries before use.
Oh, too pricey.
Yeah, I know.
It would make a nice space pirate gun.
It would make a very nice steampunk gun as well, I suspect.
That's true too. Yes.
I like the rider, not for use by children or members of the Ming Dynasty.
Looking at it, I might be able to make one.
Mm-hmm.
I have to work on that. Let's see what it's got. Standard gun handle, a little bit of bent brass, some tubes, and a collet in the front.
It looks like it's got one of those old style glass insulators you saw on antennas and transformers.
Yeah, not the kind we used to have around in the U.S. here that I'm familiar with.
You heard that, folks.
Or even a phaser.
Yeah, I can see his lineage there.
Or something out of Warehouse 13.
There you go.
There you go. Yeah, that would probably be very much at home in Warehouse 13, wouldn't it?
Mm-hmm.
Yeah.
Thank you, BP, for the links to Dr. Zarkov and Flash Gordon.
There you go.
And all I can think of now is, oh boy, if Pearson had one of those, we would have had a big issue.
There you can tell. Serious astronomer who loves her science fiction. Oh dear. Oh, okay. So where should we go next? We did the wiki.
Well, let's go quickly with new moon this weekend. Tomorrow's new moon, and also the Leonid meteor showers.
Moon on Monday. Oops, sorry, wrong one. Sorry, I'm showing my age there. Oh dear.
So hopefully you got some clear skies to check out the Leonid meteors.
Yep. Okay. What else have we got?
Let me put American Meteor Society. Let me put that link in there. They have a pretty good list of meteor showers, major showers, minor showers, and even in between showers too. So let me put that in our chat room, and that's one to bookmark as a favorite, so you can constantly look them up and see what's coming up. So they got 2017 major meteor showers, class 1, 2017 minor meteor class shower, that's class 2, I mean. And then keep on going, variable meteor showers, class 3. So there's a whole bunch of meteor showers. I know I've been out sometimes and during one shower, and I've seen like 3 in a row from a different direction. And I didn't get to check this list and find out if there was another meteor shower going on at the same time. But now with this list, I'm going to print this out and keep it with me.
Okay, another good source for meteor showers is the IMO, International Meteor Organization. Yeah. The link's in the chat room there. A very nice, spiffy-looking photograph. And that was taken over Germany from Italy. It's the #1 most reported fireball event in AMS IMO history, taken by Ollie Taylor, and that was AMS event. Sorry, folks, I've just been threatened with a loaded banana. Okay, back to enough for something totally different.
I saw a nice fireball. Just barely off camera. I think was it maybe put it on space weather? Maybe.
So anyway, current most active meteor showers. Southern Taurus September 10th to November 20th. Northern Taurus October 20th to December 10th. Leonids November 6th to the 30th. The Geminids are coming up as well. They're normally the strongest meteor shower of the year. And so meteor enthusiasts are certain to circle December 13th and 14th on their calendars. This is one of the major showers that provides good activity prior to midnight, as the constellation of Gemini is well placed from 2200 hours onwards. And peak night, as I say, 13th to 14th, the moon will be about 10% full.
I've seen some nice Geminids in the past. It can be a really nice shower.
It can be, yes, and even better if you've got a dark sky location.
Yes, of course.
So, we've got the Zarkov gun there. We've got that. Something I'm sure you would have covered Wednesday, Marty.
I would have. Go ahead.
Okay. A planet orbiting a quiet star 11 light years away.
Okay. This is the carbony one, or the one with an atmosphere, possibly Earth-like?
This is a potentially rocky planet around a red dwarf star about 11 light years away.
Okay.
Now, as we're all well aware, the exoplanet field has exploded in the last 20 years. We're actually finding detections in plates from even earlier than that, which were being kept and stored by observatories. Now, of course, we're beginning to answer the questions. With thousands of planets identified around other stars, the field has gone beyond discovery to statistical understanding. We now know that small rocky planets like our Earth are common, and the most common type of star, which is the M dwarf, is the most likely host for planets. These statistics are evidenced in the recent discovery of Proxima b, a planet orbiting our closest stellar neighbor, but that's not the only planet around a nearby star. At a distance of 11 light years, Ross 128 is the 11th closest star to the Sun. Like Proxima Centauri, it's an M-class star with about 16% of the Sun's mass. Xavier Bonfils, University of Grenoble, Alps, France, and colleagues measured the star's movements using a high-accuracy radial velocity planet searcher spectrograph at the ESO La Silla in Chile. Now, it shows that Ross 129 is home to a planet, and the results have been published online and will appear in an upcoming issue of Astronomy and Astrophysics. The great news is the potentially rocky world circles its star every 9.9 days, so that's a very short year, and with a mass of 1.3 times that of the Earth. So it's kind of nice that we're actually getting now closer and closer to something that is our own planet size. Now, it's the second closest Earth-sized planet within the habitable zone of its star. Now, this is the so-called Goldilocks zone, which is defined as the region in which water could exist in liquid form on a rocky planet's surface. It hugs its star slightly tightly than in the solar system because of the star's low luminosity. Ross 129b is about 20 times closer to its host than the Earth is to the Sun, but it receives about 50% more light than we do on Earth because Ross 128 is small and cool compared to the Sun. So its light will be much redder than sunlight. What's exciting about it? Well, unlike many other low-mass stars, its host is relatively well-behaved. Our own star has burps and coughs and brings up charged particles resulting in solar flares and storms that at their worst can severely disrupt electrical equipment such as GPS, satellites, power grids. Most low-mass stars, on the other hand, are cauldrons of activity. They unleash flares much more often and much more energetic. The flares are often in an order of magnitude stronger than the Sun's, and this behavior is thought to severely limit the development of life on those planets. However, the activity decreases with the star's age. But fortunately for any potential inhabitants of Ross 128b, the star is old. It doesn't flare as often as younger counterparts do, such as Proxima Centauri and TRAPPIST-1. So while our new neighbour may have a dim old red star, it's a welcome addition to the exoplanet census. In coming years, it will be targeted for atmospheric studies, which are most efficient around nearby star systems. Atmospheric composition, specifically signs of oxygen, methane, and water, may be the smoking gun that answers the big question: are we alone?
Are we?
Well, that I don't know. To be honest, to say we are the only intelligent life in the universe is kind of hubris.
Well, let's just go with life.
It's life, Jim, but not as we know it.
That's right.
But it would be even if that life is going to be nothing but a mess of amino acids and RNA, DNA slowly beginning to combine, it's a start. It means that we're going to miss it quite likely, because by the time the whatever it is called out of the slime, we may be long gone. Of course, it may be the fact that we probably missed a lot of life in the universe because we're fairly late to the block, so to speak, and we're in a fairly quiet backwater of our own galaxy. Time will tell. I personally think that we are right now a very violent young teenage species, and if there is life out there, and it's probably avoiding us like the plague, and quite sensibly too.
Exactly.
Yeah, especially if they're a whole lot more civilized than we are.
Absolutely. It might decide they want us for cannon fodder, but we never know.
Exactly. By the way, it is 9:30 in the evening for those of us here in the eastern portion of North America, so time for a little station identification. You are listening to the Event Horizon here on Astronomy.FM radio. It is November the 17th, 2017. As I said, about 9:30 in the evening for eastern portion of North America. So universal time, it would put it at 2:30 in the morning, November the 18th. Saturday morning, 2017. So halfway through our program, don't forget we got more programming coming up after the Event Horizon. For instance, we have a Jodcast and Talking Space. So keep listening in. Don't forget, we have our chat room nice and busy right now. So come on over to the chat room during our live portion. That's where we get the most action here. So if you got a question on astronomy, put it in the chat room and go ahead and ask us, and we'll answer it on the air. Let's say hi to everybody in your chat room. We got you and me so far, Nick. We got Optronics, Glenn, Starstorm, Twist Edge, Astro One, and Black Projects. An international audience tonight for sure. Glad to have everybody here.
Yep, and of course, November the 15th, 2 days ago, saw a very important milestone for the Mars 2020 rover.
Now, what was the milestone?
Well, what it is, there was a suborbital launch from Wallop's flight facility, and they were testing a critical piece of the landing hardware for Mars 2020. Obviously, most of the drama in spaceflight occurs on seen and remote worlds in the solar system. We're not on hand to watch, for instance, the climax of Curiosity's 7 Minutes to Terror, or Beagle's bounce across the Martian landscape. What has happened is NASA have now released a new video of a key test showing what one portion of a future landing might look like, that of Mars 2020. So in the early in the morning of October the 14th, NASA launched a Black Brant 9 suborbital sounding rocket with the Advanced Supersonic Parachute Inflation Research Experiment called Aspire. Now, this was conducted from its launch facility in the Mid-Atlantic, which is Wallop's flight facility in Virginia. The goal of the mission, the suborbital mission, was to test a copy of the parachute that will slow down the Mars 2020 rover as it comes in for landing at 12,000 miles per hour. That baby is shifting. Now, as... oh, yes. I see there's a comment in the chat room that everybody thought we were a program inside the Matrix, and someone is playing a game of marbles with our galaxy.
There you go.
Somebody's been watching Men in Black again. Anyway, it's quite a wild ride, says Ian Clark of NASA JPL. The imagery of our first parachute inflation is almost as breathtaking to behold as it is scientifically significant. The second stage and onboard cameras give an amazing view of what a spacecraft hurtling towards the red planet looks like as it unfolds its parachute. This is no ordinary parachute. Landing on Mars, as we all know, is challenging, as well as the tenacious Martian atmosphere is just barely substantial enough that engineers have to take it into consideration. The hefty parachute made of nylon, Technocora, and Kevlar will deploy at 100 miles an hour. So that's going quite a bit. Now, having said that, when the command modules were re-entering, they were going at a fair clip too. And this is kind of similar to the testing that was done originally with the command module for Apollo, for Gemini, and for Mercury. And it's kind of the same type of testing as they're doing currently on Orion. Thank you, Black Project. He's put a Black Brant 9 Aspire test link into the chat room for the video. Now, what happened was the rocket took Aspire to an apogee of 32 miles, 51 kilometers. The onboard sensors triggered 42 seconds later at an altitude of 26 miles. So as the craft reached 1.8 times the speed of sound, the sensors were signaling that external atmospheric conditions and speed had been met to simulate Martian atmospheric entry. And so the parachute deployed, and this was just after 35 minutes from launch. So Aspire splashed down about 32 miles down southeast of Wallops in the Atlantic Ocean. Contrast this with the 3-hour balloon test for the first Viking landers carried out over the White Sands Missile Range in southern New Mexico back in July and August 1972. Of course, the other important thing, and everybody has forgotten, is this is very important. This technology is very important for man on Mars, because they have to decide eventually how the manned Martian lander will land. Will it be a parachute entry, or is it going to be a controlled rocket burn to bring the spacecraft safely down on the planet? By exploring all these options with our rovers and previous space missions, we have a formidable arsenal of technology coming into play. Do we do the sky crane job, or do we rely on a parachute, or just do we do a burn, start re-entry, and then burn rocket fuel all the way down to the planet's surface?
Or the combination of both.
Or as a combination of both. Now we are getting a lot more information on how this technology will stand up, if it will survive in our thicker atmosphere at these speeds. It means we can go forward and perhaps start seriously considering how we're going to visit the Red Planet. Obviously, missions to Phobos and Deimos not an issue. It's just a rendezvous, and then either decide if you're going to just land or just tether yourself to what, in case one of these particular satellites could actually just be a loose amalgamation of rubble. Glenn in the chat room is suggesting we will glide in like the shuttle. No, I don't think so.
I don't think there's enough atmosphere for that.
There isn't. No. And the thing is, that means you're going to have a spacecraft that's in a horizontal position, and that would need a runway built.
It's to stay at the surface, to stay at altitude with that air, you probably need to be about 600 miles an hour.
Yeah.
Or more.
So basically, we have a lot more options. The information we're going to get when we actually, for real, land Mars 2020, I suspect will actually be funneled into manned Mars. Mm-hmm. So, long way to go yet. However, yeah, it is a good thought, Glenn. And to be honest, I want to point out this is one of the important parts of this show. It's the audience, it's the chat room participation. And Black Projects has suggested Mars gliders would need a wingspan possibly about half a mile wide. This is the point of the shows, folks. We want you to listen to what we're gabbing about and start chipping in your comments in the chat room. Put in your links as well, because they're all part of the show. Yeah, Marty and I quite happily could probably spend half an hour or so longer talking away, but the best thing about it is you guys get involved. And I think that's the greatest thing about these shows, Marty, and I'm sure you agree, is audience participation. Whether it's Starstorm sitting beside me, chumping in with her tuppence, halfpenny, or it's people in the chat room, and putting links in as well. Links to YouTube user ESA, for NASA, for all the other space agencies. That is the thing for us, is the most important part of it, is audience participation. And I think this is one of the things we really like about doing these shows, folks, is we've got you folks in the chat room taking an active part, and some of the cross conversations are just absolutely fascinating and absolutely wicked. That's what it's all about. Okay, Marty, I'll get off my soapbox.
It's okay. Let's see, I got an article here of from is it SDO? Let's see, where's this from? Well, anyways, they're detecting pulses in solar flares. Let me put that up. Yeah, that's kind of interesting. So instead of just like flares, no, these things are actually kind of rippling and pulsing. Something a little bit different, something never seen before. So that's just getting equipment more and more sensitive in order to be able to do that. Is what's happening there.
Now, Optronics has asked the question in the chat room, you put satellites in orbit with balloons? No, what it was, they tested the Viking landers using balloon trips around the White Sands missile test area. It was an easier way at that point to actually simulate a landing. Take the lander up in a hot air balloon and then then control it and just do your descent and test out your systems.
I remember a long time ago there had been some plans for having sort of a balloon drift around Mars, gets warmed up with the sunlight, and then just kind of drift around, have a tail that would kind of drag along the ground, and take samples of the air and measure the atmosphere as it goes along, basically heated by the sun, so it goes up, and the daytime it would just cool back down and settle down to the ground until it got some more sunlight again.
Well, I think one of the things, harking back to a BBC docudrama called Voyage to the Planets, in the section about Mars, they're actually deploying a barrage balloon to venture into Maris. What's it? I can't remember that. The Grand Canyon on steroids on Mars. Varanaris.
Oh, yes.
And that would be a terrific way to explore Mars, because yes, you're going to have situations where the astronauts have to hunker down during solar storms because of the radiation. Mm-hmm. But you can leave your automatic probe or it to navigate its own way and explore whilst the guys or the astronauts are hunkered down in their radiation shelter, waiting for the radiation levels to drop sufficiently for them to go back out and pick up again on their experiments. Mm-hmm. That would be a great way to actually explore Mars, full stop. Deploying a balloon to travel the length of this great rift, this great gash in the planet. Do you think we should be running NASA, Marty?
Fun to watch it bounce back and forth in between the canyon walls, though.
Yeah, it would happen, particularly with some of there would be still air current. We know there's air current because of the dust storms, the zephyrs. Mm-hmm. But having said that, our equipment is more robust these days. It's more sensitive. It's a lot more tolerant to where it is going. When you think we sent Spirit and Oppie, back in 72?
Something like that.
Yeah, because Curiosity was 2012. Viking was around that time, was 72-ish. Okay. But when you consider Curiosity's 7 minutes of terror as it descended, these probes are still. One of them's been shut down because it can't really do very much anymore. But there's still one of them still going. It's still doing science, and I think one of the first things we should do when we get to Mars with a human crew, I think we should find that poor little probe, fix it, and send it back on its way. Get it back doing science, because it's sitting there. It could be upgraded. It could be put back into use, and it's science on the cheap, folks. Mm-hmm. You don't have to pay to send a new rover because you've updated an existing rover, or both of them even, and they're able to continue on and do even more science. It's science on the cheap that's begging to be done, I think.
Sure. Not too cheap, though.
No, but if you think about it, it is cheaper than a new rover.
Mm-hmm.
And having stuff we know that works and has survived so long and so amazingly well, everything that Mars has chucked at it, that's going to be interesting. I really think that should be one of the mission objectives for man on Mars.
How about we do a little bit of what's up with the sky?
Yep, okay. That's this week's Sky at a Glance. I'm ready for that, Marty.
Go for it. And I'll add a couple in there, too.
Yeah. Okay. Thanks to the guys at Sky and Telescope for these really wicked links they send me an email, because they really make doing the show fun. Okay. So, the Sky at a Glance for November 17th to the 25th. 2 challenged planets. As the twilight fades, looking low in the southwest for Saturn and Mercury. They're about a fist at arm's length apart. Binoculars will help. With the moon not yet back in the evening sky, take advantage of dark nights to explore the galaxy inside the top right-hand corner of the Great Square of Pegasus, a bunch of magnitudes 11 to 13. Use a 6-inch or larger telescope and use Sue French's Deep Sky Wonders article, chart and photos in the November issue of Sky and Telescope. I'm going to plug it because it is part of the article, and I've actually met the Frenches, and they're wonderful people. Mm-hmm. For a deeper challenge with a larger scope, the Rich Able 194 Galaxy Cluster in Cetus, and there's a column and photos on the same issue, page 58. For Saturday the 18th, around 7 p.m. this week, the Great Square of Pegasus stands on its level, positioned very high towards the south. It's straight overhead if you're as far south as Miami. Its right western side points very far down towards Fomalhaut. Its eastern side points less directly toward Beta Cetus, not as far down. Looking lower if you have a good view to a dark southern horizon, and if you're not much farther north than, say, roughly New York, Denver, or Madrid. Picture an equilateral triangle with Fomalhaut and Beta Cetus as its top two corners. Near where the third corner would be is Alpha Phoenicius or Akara in the constellation of the Phoenix. It's magnitude 2.4, not very bright, but it's the brightest thing in its area. It has an orange-yellow tint. Binoculars help to check. Have you ever seen anything of the constellation Phoenix before? Now, new moon is exactly at 6:42 a.m. Eastern Standard Time. Sunday, a mere 20 minutes or 30 minutes after sunset, scan with binoculars just above the southwest horizon for the crescent moon and Mercury as shown in the middle panel. They're about 8 or 9 degrees apart. For North America, Saturn is to Mercury's upper left. Orion is clearing the eastern horizon by 8 p.m. this week, depending on how far east or west you are or you live in your time zone. The 3-star belt is nearly vertical. High above Orion shines orange Aldebaran. Above Aldebaran is the little Pleiades cluster, the size of your fingertip at arm's length. Far left of Aldebaran and the Pleiades shines bright Capella. Monday, whilst twilight is still bright, look low in the southwest for the waxing crescent moon. Left of it by about 3 degrees for North America is Saturn. No more than 20 or 30 minutes after sunset, use binoculars to hunt for Mercury. 7 or 8 degrees below them, as shown in the middle diagram. Tuesday, the crescent moon is now thicker and higher in twilight. It points lower right towards Saturn. Mercury again glimmers lower right of Saturn before setting. Wednesday, 2-point fuzzies, naked eye, the Andromeda M Galaxy M31 and the Perseus double cluster are two of the most famous deep sky objects. They're both catalogued as magnitude 4. And in the good sky, you can see both with the unaided eye. They're located about 22 degrees apart, very high towards the east early these evenings. To the right are Cassiopeia and closer below Cassiopeia, respectively. But they look rather different, more to the dark of your sky. See for yourself, they're plotted on the all-sky constellation map in the middle of most good astronomy magazines, Sky and Telescope, Astronomy Magazine, Sky at Night, and there are others. Thursday, does the sun already seem to be setting as early as it ever will? You're right. We're still a month away from the winter solstice, but the sun sets at its earliest around December 7th. So if you're near latitude 40 degrees north, and right now it's already sets within about 3 minutes of that time. Surprising result of this, it sets about as early on Thanksgiving as it will on Christmas, even though Christmas is much closer to solstice. This offset is made up by the opposite happening at sunrise. The sun doesn't rise its latest until January the 4th. Blame the tilt of the Earth's axis and the eccentricity of the Earth's orbit. And then we are back to Friday, and I'm sure we'll cover that then.
Mm-hmm. Got Mercury greatest elongation coming up.
Yep.
This coming, Friday the 24th. 22 degrees, so good time to go do some Mercury observing. Kind of low on the horizon right now, but it's getting better.
If you have a nice unobstructed horizon, that's even better. But
Yes, indeed. All right. So let's see where we want to go. We got about 10 more minutes left in the show. So,
Double stars in Pisces.
what was that?
Double stars in Pisces.
Some stars. What stars are in Pisces?
Double stars. Go
Double
fishing
star-
for double stars in Pisces.
Well, you want to
This
go
is a
fishing for
Bob
double
King
stars?
article.
Okay.
Yeah. Okay, so Pisces the fish. It's a faint constellation that meanders below and above the eastern side of the Great Square of Pegasus. It's best known as a great place to hunt faint galaxies and galactic clusters. Pisces is equally rich in double stars, many bright enough to see and split in a small telescope. So, if you're using a 10-inch f6 scope, you can pick up about almost 20 pairs over 2 nights. So you can move literally one from one to the next over on a mission of discovery. The double stars fall into 2 broad categories: unequal pairs with a significant magnitude difference between the primary and secondary, and equal or nearly so duos. Most are fairly easy to split at low magnification, about 50 to 75x, with companions no fater than about 10th magnitude. Only a few would require 200x or higher to pry apart. Now, most people, I've seen a lot of people using remote telescopes to do this as well, to image double stars. And I tend to think using something like a half-meter astrograph for double stars is kind of overkill. But you see people doing it, and I'm thinking, you're mad.
Better resolution.
Yeah.
More aperture, better resolution.
Yeah, good old-fashioned aperture fever. That's why I'm getting a 20-inch Dob, not because I want to go double star hunting and stuff, because I like hunting comets. I like imaging comets. I like imaging the moon. And there are places on the moon that require aperture.
Mm-hmm.
Obviously, I'm talking about some of those really nice rills, like Hadley Rill,
Yes.
the Apennines, and some other stuff. You can also go ghost crater hunting too. So the bigger the mirror, the more light you get, and the more you can actually resolve some of these really small and faint craters. And to be honest, double star hunting can be fun.
It is.
It is.
Especially when you get a challenge of how close 2 double stars can you actually see. It's a good way of testing your optics,
Yeah.
for collimation, and for testing your night's viewing. By getting a good list of double stars, it's one of the first things you really want to do when you go out is check some double stars and see what you can resolve. So then you'll get an idea of how well your optics are going to work for that evening.
So as I say, the article does give a list of stars, and it gives some ideas on magnification. And so for one of these stars, he used a 214th magnification to split these two equal magnitude stars into side-by-side pearls. For 34 Piscum, he's saying the large magnitude difference made the seeing the secondary difficult. So maybe somebody else will have better luck.
Mm-hmm.
So this is an f6. It's not fast, not a very fast telescope. Something maybe like an f4.5 or an f4 or better might help, I would have thought. That's just my personal view. My Newtonian is f4.5. The half-meter light bucket I'm ordering next year, is going to be f4.5. That's going to be fine for me, because that's going to let me go after some fairly faint comets. I will be using servo cap because of derotation, and I will be having to go totally to the dark side and get a CCD.
Yeah.
And I've seen a nice Attic 325 or 328 plus. It's got a beautiful Kodak sensor on it, and I am told that is the one to go for what I intend to do. I admit it. If I'm bored with the comets, I can switch to the moon. I can crater hop. I can look for rills. I can look for mountains. I can look for peaks. You can look for runs of craters. You can look for overlapping craters. The moon is never a boring object. It's just one of those things. There's the actual changes in the lighting from the sun is such that there's always something new to learn.
Mm-hmm.
And this is where there are like places like LPOD, Lunar Picture of the Day website, really does come into play, because not only can you get to see the amateur pictures and what equipment they used, you get to see some of the space probe images from Cayuga, from Changi 1, from LRO, and it allows you to access the immense resource that's provided there. So you can go there, you can image, and you can compare it, and then you can really say, yeah, I got it. And some of these craters, and some of these features on the moon, because of the forever changing sunlight, are a real challenge.
Mm-hmm.
I think that's the greatest thing about the moon and about lunar imaging, is the fact you are constantly having to change your approach, your mental attitude to what you're doing. You can't say, oh, well, if I do this, I'll get this. You won't, because it may be you have 3 nights where you can't get out there, you can't image, and of course the sun angle has changed. So you're now going to be seeing that crater you've been working on perhaps for the past 3 months with a different aspect from the light. And it's that aspect that really makes the whole thing worthwhile. Yeah, I know that the guys who do the fuzzies and the globs and the comets, some of the really faint comets, so, oh my God, the moon's here. We're going to have to quit. But you know what? You have periods of the night where you're not going to have the moon.
Mm-hmm.
So that's when you do your deep sky stuff. When the moon comes up, you go to the moon, and then you start having a little bit of fun. Find a new crater or a new object to image under different and varied and changing conditions. And to be honest, it's going to take the rest of your life to get to know the moon as a whole.
And the more interest you get in the moon, the more you'll notice that it's missing that night you want to go out and you got clear weather. So if you use the moon as a major plan, but you're really like a deep sky observer. So yeah, you try to observe the moon, then it's like, oh, well, I can't. I guess I'll have to go to my favorites, deep sky stuff. That's the way the calendar will work into your advantage that way. So.
Well, there's advantages to everything. And the advantages, as the moon is waning, it's moving more and more to a morning and daytime object. So you've got dark nights. Mm-hmm. You can image the moon, you can image the planets during daylight.
Yes.
And that not very well, but it's still a great challenge.
Yes.
And the thing is, astronomy's greatest thing is it is always going to be a challenge, because you've got the weather, you've got people deciding they're going to have a party on the one night you've got a perfectly dark sky, and next door decides they're going to start launching Chinese lanterns and everything. That's of course when you get your shotgun and start blowing them out the air.
That's right.
Ack time. Blah, blah, blah. What do you think you are? Oh, I thought you was invading aircraft. Put the old ack gun out.
There you go.
I'm not. By the way, I'm not telling you to go and do something illegal. I am not going to go do something illegal. And to get a shotgun out and start shooting Chinese lanterns down in a built-up area will get you a visit from the police.
Yes, indeed.
Right. We've got minutes.
Yeah, we've got about 1 more minute left. Let's see. I got one little thing we can jump on real quick here. I heard recently there was a conference of flat Earth people. Yes, they had their own conference, flat Earth people. You know, I'm thinking about, I don't know which one this is, but if they have an annual, flat Earth people have an annual flat Earth conference, you might want to ask them, what exactly is a year? Might make them go, what is a year?
This is the awaiting to the USS. What's this whole ship called? Miranda. Thank you. The USS Miranda. Captain Savick, please beam the 3 of us away. Bring us home fast.
Yes. Time to get out of here, everybody.
Have a good evening, everyone.
appreciate everybody that's been in our chat room tonight. Really, thanks to everybody and everybody listening in. Don't forget, we got coming up a Jodcast and Talking Space coming up right after the Event Horizon. Thanks, everybody, for joining us. And yes, we will be here next week. So see you all again next week. Good night, all.
Look up.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM. There I was, doing my thing.